This is an activity that we're going to be doing throughout the year in math reasoning. It's called a number line. As you'll see, you have this line, and there are 7 points on it. 5 of them are letters, A, B, C, D, and E, and 2 of them will always be numbers. The numbers are very important because it sets your scale, and that's the first thing you should do when you approach a number line is determine what scale you've been given. So how you would do that is you would take a look at the 2 numbers, and I'm going to use the tools in the Smart Notebook to help us out. So I'm going to make a line, and that line I'm going to put on my scale from here to here. And so we want to find out how long that line is, or in other words, the difference between 0 and 20. So what I could do is I could actually say that that distance is 20 minus 0, which of course you know equals 20. So my scale is 20. From 0 to this point is 20. So then ask yourself, where else do I see that distance on this line? And let's take a look, and if I were to copy this or clone it, where else can I see that distance? Well, that looks really much like it, just like that. So that means that this distance is always 20. So don't feel that you have to always solve the letters in order. As a matter of fact, in this case, I find that C on this number line is easier to solve than many of the other letters. So I feel that C must be 20 more than from this point, or 20 plus 20. So what I'll do is I'll come down here and I will grab a pen and mark this as 20 plus 20, which is 40. Now for your explanation, because all number lines have to have each letter explained, you can come down here, and I'm just going to type it because it'll be quicker. And that letter C is equal to, I'll just say equal to 40. And your explanation could be the distance from 20 to C is equal to 20. And you can prove that on the number line. Feel free to mark up this line as much as you'd like. You can even put numbers that I'm not asking for, and if it comes up, I'll show you where you might actually put extra numbers. So the next point we might look at, and it's up to you where you go from here, but I am looking at B and saying, you know what, I really feel I know what B is. I'm going to change my color up so this way you can see the difference. And if I look at 0 and 20, B is right in the middle. And so what is number is in between 0 and 20? Well, that would be 10. And so for my explanation, I'll come back down, and I'll put that over here, and I'll say that B is equal to 10, and the reason is it's the distance. And you know what? I'm going to change that. I'm going to say the midpoint. That's a great word to use in this. The midpoint of 0 to 20. Because when you say midpoint, you're talking at the very point that is the middle of 0 and 20, which we know is 10. So that would be a good explanation for B. Now that you know B, you might find that A is a very easy number to find, because A is now the midpoint of 0 and B. So let's go over to A, and the midpoint of 0 and 10 would be 5. There are other explanations you could use. You could have said that the distance from 0 to A is 1/4 of the distance between 0 and 20. That's also a good explanation. I'm just going to stick with keeping it simple, and I'm going to call point A the midpoint of 0 and B. Now what's important is that you would have had to have found B first. Like I said, it doesn't matter which order you do these in. And we'll call that the midpoint of 0 to 10. Now, looks like I have A is 5, B is 10, C is 40. Now let's take a look at D. Well, you know what? Actually, maybe I'll take a look at E first, because E looks like it's the same distance from 40 as 20 is to 40, or in other words, another one of these. So let's just prove it. We'll clone that. And this is where a little piece of paper or index card comes in very handy. And I'll show you that in class on how to use that. But I'm basically using this tool as I would an index card, and just take a little line on a card and hold it up and make sure the distance is the same. I would refrain from using rulers because the scale doesn't match up with the markings on a ruler. But these markings do match up, and this is 20 more than 40, so E must be, let's go to, this will just go black, and E must be 60, because this distance is also 20. Sometimes on the top of the lines, I'll put the distance up here. That doesn't mean the number is 20, it means the distance from here to here is 20. And that allows me to recognize that I go from 40 and add 20 more. So I'm going to come down here and I'm going to skip a spot and go to E and say that E is equal to 60. And my reasoning is it's the same distance from 40 as, we'll say, 20 is from C. So this is where you can feel free to explain your reasoning in different ways. I would just refrain from saying 40 plus 20 is 60, only because it's a little misleading of where you got the 20 from. Here it's very clear. I got this 20 from going 20 to C, because that's the same distance. I've proven that up here. Now I think D is a bit easier to understand. I'm going to go back to D now, and I'm going to say, well, if this is 40 and this is 60, and this is right in the middle, the midpoint of 40 and 60 would be 50. And now I can go to my explanation, and once again, you have lots of different ways to explain it. You can keep it simple, and I'm going to just say that D is the midpoint, is 50, and it's the midpoint. This is really big. I'm going to shrink that in a second. Mid 50, it's the midpoint of 40 and 50. 60, I'm sorry, 60. And let's shrink that a little bit, because that is way too big. Let's go to 28. Here we go. That's a little better. Actually, we'll make that a little bit bigger. Okay. All right. So I have a point for A, B, C, D, and E, and most importantly, because you will not get full credit on a number line unless I see explanations, here are your explanations. Feel free, once again, to mark up the top of this line as much as you would like. It's really important that I do see your work. Feel free to put extra points in, letters that I didn't even ask for. At this point, what I'm going to do is just to prove all these numbers, I'm going to go in sets of 5. If this distance is 5, then this is 5 more, which is 10. This is 5 more, which would make that 15, even though I didn't ask for it. And that proves that this is 20. I might go and say, well, if this distance is 10, then 10 more would be 30. And once again, although I'm not asking for these points, it does prove that this number line is accurate. That's how to solve a number line. We'll do a few more during the course of the year that you'll be able to find on Schoology, so you can have an example of how to solve a number line. Hope you enjoyed it. If you have any questions, see me in class.